So I want you to take your exam. If you're playing along at home, I'd like for you to take your exam and to look at the questions and divide them up into 3 categories. First of all, the questions that I did not understand. What does this question even mean? Then, we want to have a second category. Did understand, but could not do. Didn't know how to do it. I remember I saw this somewhere. What the heck does it mean? Hello, Riley. And then in the third category, questions could do, but executed poorly. In other words, silly mistakes. So I'm going to ask you in just a minute to get both your multiple choice and your free response, and to take all of these questions here and divide them up into those 3 categories. And you'll have 10 minutes to do that. Everybody ready? Well, yeah. Right. Ready? Go. All right. Now what we're going to do is we're going to take these questions, did not understand, did understand, could not do, could do, but executed poorly. So we're actually going to have a different approach for each one. Because if there is a question that you did not understand, 8 or 9 times out of 10, that's because there is a word or a symbol that you didn't know the meaning of. So this is all about definitions or vocabulary. There was some word or symbol that you simply didn't know what it meant. If you don't know what that prime of x means, you're going to have a bad time. Right? Did understand but could not do comes down to not knowing the relevant theorem, or maybe definition. Not knowing the relevant theorem, because it's really the theorems, including derivative and limit rules, properties, that allow us to solve problems. Could do but executed poorly, that's a hard one. That comes down to usually a brain flip somewhere in the execution of either algebra or calculus. Hunting those down and getting rid of those is really tough. And the way that I found for myself to make that happen is that I have to do a basic set of skills to try to make sure that I'm really right. And one of those things is going to be to identify typical errors that I make and talk myself through why they're wrong and what the right way to think about it is. Identify common errors and practice thinking correctly. Practice doing it right. This is the big deal, guys. If you practice doing it right, when you get to a test, what do? You do it right. If you practice doing it wrong, when you get to a test, what do? You do it wrong, which means that your homework, if you're not doing your homework right, you're actually hurting yourself walking into that test. You understand what I'm saying? If you're doing your homework wrong, you're actually making your life harder when you walk into the test. And that means that you want to put a premium on doing the homework right. We identify common errors. Sometimes it's a matter of formatting your work correctly. That may include things like putting labels on your calculations. Labels, complete sentences with an equal sign and everything. There may be some other things about format that we want to look at. And then finally, there may be a specific algebra mistake that you're commonly making that you want to identify and say, let me not do that again. So this is going to be the hard part. And there it is. Now the question is, which one of these should we cover? Well, let me explain my full plan. My full plan is I'd like to cover any multiple choice questions that you have today. and any questions about number 1 free response if we get to that. I'm going to do a video that covers numbers 2 and 3, and that's what you'll watch for class on Monday. Okay. So at this time, are there any questions that you have about the multiple choice? Let's start with any questions you did not understand. Number 17. Oh, yes, that is a symbol that you need to know. Is that f prime plus a pi? Yeah. Okay. So this is the derivative from the right. And it means the limit as x goes to pi from the right of the difference quotient. Okay? It's called the derivative from the right, and there's a corresponding derivative from the left. And it looks exactly the same, except that you're taking the limit on the left of the difference quotient. Glad we cleared that up. Any other questions you did not understand? Yes, sir.
Number 11.
Number 11.
Yeah, 11.
Yes, I would consider number 11 the hardest question to understand because you had to look at the language here. Let's stop and see what they've told us so far. First of all, they have told us that f and g are functions that are differentiable everywhere. What does that mean to me, the problem solver? It means that I don't need to worry about any kinds of non-differentiability. Moving on. If g is the inverse of f, let me translate that into math. G is the inverse of f. You see how the translation goes? Now they say if g of negative 2 is 5 and f prime of 5 is negative 1/2, then g prime of negative 2 is. Since I have written g as f inverse, I'm going to take all this information and I'm going to rewrite it in terms of my new information. What they're telling me is that f inverse of negative 2 is equal to 5. And what they want is f inverse prime of negative 2. And as soon as I see that, I go, oh, I've got a theorem. It's called the inverse function theorem that tells me what f inverse prime is. It is 1 over f prime of f inverse of negative 2. And hey, look at that. F inverse of negative 2 is 5. And hey, look at that. F prime of 5 is negative 1/2. And so I get negative 2. It was all one grand glorious exercise in substituting. That's it. But I needed to translate g as the inverse of f into a useful form. It's the power of language. Good. Any other questions you did not understand? Yes, sir.
Can we go over 18?
18. What did you not understand about the question?
I understood what to do with more bad. Oh wait, no, I'm on bad execution.
Okay, yeah, let's come back to it. Keep it. Number 3. Okay, what did you not understand about the question? Yeah, that'll work. Yeah, that's probably poor execution. You understood the question. Any others that you did not understand? Good. That's a pretty small set. Let's move on then to questions that you did understand but you could not do. Heidi,
Number 20.
number 20.
Very confused. No, I'm not confused. I mean, I'm confused because I thought I did it right, but I don't know.
Apparently, x over square root of 2x minus 3 plus the square root of 2x minus 3.
Okay. A smart student taking multiple choice tests is going to scan the answers quickly. And when you scan those answers, what you notice about them is that they're all one term.
Right.
And you recognize that you've got a product here, so you figure I'm supposed to get two terms, and that means I'm probably going to have to combine terms. So ahead of time, you kind of know how this is going to go. We're going to end up with two terms as a result of product rule, and we're going to have to combine them together. So now we'll patiently do that, one derivative rule at a time. All right, Heidi, how does it go?
Okay, so I started by doing x times 1 over the derivative of the square root of
Yeah.
2x minus 3.
Here we are at the end of the exam. We probably have a little bit of time left over. Let's take our time to do it right. So there's product rule. Good. Now,
Times 1 over 2 times square root of 2x minus 3 times 2x, the derivative of 2x minus 3.
times the derivative of the inside. Plus, this term is easy. Okay, and the derivative of 2x minus 3.
2.
And so we get our first piece of good news, and that is, well, here's our answer. Bad news doesn't look like any of the answers. Good news, it's slow and careful, and we're pretty sure it's correct. All right, now tell me where to go from here.
Well, I canceled out the 2's.
That's right. 2 divided by 2 is definitely 1.
And then, okay, so then I didn't know what else to do and I was running out of time, so I picked b because it was x over 2x, the square root of 2x minus 3.
Okay.
That's all
Yeah.
I did.
So let me tell you why actually B is a really bad answer, other than just being wrong. But B you can know ahead of time is a bad answer. Assuming this derivative is correct, and you are. Notice that the derivative is equal to the answer you picked plus something that is not 0.
Right. Well, I realized that, but I was kind of running out of time, so I just...
So pick any other but that one.
Okay.
You see what I'm saying?
Yeah, I figured I was being dumb, but then I was like, but it looks most like the answer.
Yeah. It's what we call a distractor answer. And they actually throw those in there. And they throw those in there for people that are kind of like that. There's another distractor answer right there, 1 over root 2x minus 3.
Yeah, I
That's-
wasn't going to pick that.
That's for people that forget about product rule and chain rule and just take the derivative of each factor and, well, there you go. Have fun. Yeah. And then there are some others. All right, so let's consider now how we really should do this. Yeah, I need a common denominator, and I always get a common denominator the same way. I multiply by 1. So, how do you give me the appropriate 1 to multiply by?
The square root of 2x minus 3.
Absolutely. Keep going.
Okay, then you, it becomes x over the square root of 2x minus 3 plus 2x plus 3. 2x minus 3.
It's 2x minus
Yes,
3.
2x minus, okay, 2x minus 3 over the square root of 2x minus 3.
Don't be fooled by its fearsome form. When you multiply the square root of something times itself, you get that thing. The square root
Okay,
of
that makes sense.
whatever times the square root of whatever is whatever. And then the rest follows.
Okay, that makes sense. I don't know why I didn't do that.
Good question, and a good number of possible reasons you might not thought of that. The right way to think of it is to think common denominator, multiply by 1.
Mhm.
Good. Other questions that are in the category of did not know how to do.
Number 1.
Number 1.
Same.
You say special limits. Does this remind anybody of special limits? Yeah,
You do the x minus 1 over x and sine x over x.
sure does. I have two special limits right here. And if I don't know how to do it, then I'm at least going to write out my two special limits. What are the values of each one of these limits? The top one is, the bottom one is, the bottom one. Now that I look at these, do you think I might be able to get from here to there?
Yes.
Yep. Here is a basic thing that smart test takers and problem solvers everywhere do. If they are stuck on something and they know some things that are related to those things, they will actually write them down. Did you notice that as soon as I wrote it down, you knew what to do?
Yes.
Well, you can do that for yourself. If you look and you recognize a pattern, don't think that pattern in your mind, write it down on the page so that it has the opportunity to then spark an insight. I do that all the time. Okay, good. Any other questions in the category did not know how to do? Yes, sir.
16.
At what point on the graph of y equals 1/2 x squared is the line tangent parallel to the line 2x minus 4y equals something? 3? Doesn't matter.
Equals 3.
Okay. When you have a question, the key thing is to translate the core of that question into math. So, what does it mean for a tangent line to be parallel to this line?
Of the slopes to be the same.
Both have the slopes are the same, that's right. Can you find the slope of this line?
Yes.
Yes, what is that slope?
Y equals 2 equals 4x.
So slope is a half, right? Can you find the slope of the tangent line to this curve?
Yes.
Sure, what's it called?
Derivative.
Derivative. And dy dx here is equal to 1/2 of 2x, which is equal to x. If the slopes have to be the same, then automatically I have the x-coordinate of the point where the slopes are the same. Now that I have the x-coordinate, I need a y-coordinate too, and the answers remind me of that fact. And how do I get the y-coordinate? Plug it into what though?
Original equation.
Which one? I've got two.
The first one.
Why do I want that?
Because it sets out
What
the
point
graph.
on the graph?
On the graph, that's right.
That's exactly.
Then you sub it in which one?
The point that is on the graph, because they asked for the point on the graph. That's right. And so I get y of 1/2 is equal to 1/2 of 1/2 squared, which is 1/8. And now we have a point. Good. Any other questions in the category of, yes, defect? Number 9. Number 9. You say you want a revolution. Eagles joke, sorry. If C is the number that satisfies the conclusion of the mean value theorem for f is equal to x cubed minus 2x squared, is that right?
Yes.
On the interval 0 to 2, then C equals. T-Bay, tell me the conclusion of the mean value theorem. If f obeys some stuff, then. Open or closed? Open, right. What's our B and A in this case? Yeah. So when I write down my conclusion of the two-value theorem, see how I'm writing it again? Same principle as last time, right? I write it down with as much plugged in as I possibly can here. And in fact, I should plug in and find out what is the value of f of 2. And when I plug in, I find out that f of 2 is in fact 8 minus 8, which is 0. And f of 0 is easily 0. So therefore, I'm really looking for where f prime of c is equal to 0. And what is f prime of c? F prime of c is equal to 3c squared minus 4c. Right? And so now factoring is my friend. And so I factor and get either c is equal to 0 or 3c minus 4 is equal to 0, so that c is 4/3. Question.
Wait, what? Wait, so,
F prime, 3x
Right.
squared minus 4x. F prime of c is 3c squared minus 4c equals 0.
right,
Factor.
oh.
Sure. And so now I have these, and I need to do what smart mathematicians always do. I need to do a domain check. Is c equals 0 in my domain? No, it is not. They didn't trick you. You tricked yourself by not being careful. They just provided the opportunity for you to demonstrate that you understand the difference between an open interval and a closed interval, and some of you demonstrated that you do not. But next time, we'll pay close attention. Yes, sir.
Number 7.
Number 7.
What's the first one?
Ah, yes. I was proud of this question. Which of the following is true about the graph of f? Symmetric about the origin and symmetric about the y-axis are related to, yes, two theorems that we have, or maybe two parts of one theorem. Right. Symmetric about the origin looks like this, where a graph has a point x comma y, and if you go take a line through the origin, it hits right down here at negative x comma negative y. And what that means then is that f of negative x is the opposite of f of x, which we call odd. And so it is a theorem that all odd functions are symmetric about the, have graphs symmetric about the origin and vice versa. All odd functions have. Meanwhile, symmetric about the y-axis means that if I have a graph and it has a point x comma y, then if I go take a line directly through the y-axis perpendicular right there, I will hit a point negative x comma y. And what this means about my function is that f of negative x is equal to f of x, and we call that kind of a function an even function. So there's also a theorem that even functions have graphs symmetric about the y-axis. So I take a look at my function now, and because they're asking me about symmetry, I'm going to do an even or odd check on my function. And when I do an even or odd check on the function, that means taking and substituting negative x for x and seeing what pops out. Don't forget to group. See, I've got negative x squared going on right there? Don't write that as negative x squared. And this is equal to negative x over root x squared plus 1, because negative x quantity squared is x squared plus 1. And this is exactly equal to the opposite of f of x, which means that my function is odd and it is symmetric about the origin. Better? What's that?
I just plugged in points and made myself a graph.
See, and you can do that on multiple choice, but you couldn't do that on proof.
Yeah, I can, yeah, but.
But that's smart. All right, any other questions? Yes? There's all right. we have to evaluate this thing, we have to find a value for it. And so that means that I'm going to want to work inside out. I'm going to start on the inside, and I'm going to find the inside and work my way outwards to the outside. Okay, do that. Now, I don't want you to skip to the end. I want you to start with the inside and take me through it carefully. Okay, so we're going to write that as f prime of x. You want to label that, and f prime of x is equal to e dx. All right, keep going. Good.
I'm actually here.
Yep.
And that's, I remember like, the act, I'm sure that the act, over the act, over the act, after the
Dx over dx is 1.
yeah, but here is like,
If that were true, wouldn't your derivative always be 0 for e to dx? At any point? Yeah. So the problem is that the differentiation happens before the substitution. It has to. Because in the differentiation, we are assuming that x changes, right?
oh,
Yeah, exactly. Okay. Now that I've got f of prime of 2 is equal to e squared, I'm going to substitute that value into here. And what is the element of e squared? Oh, that's 2. And we're done. See, if I had asked a slightly different question, Jackson, if I had asked what is d dx of f of 2, that would be d dx of e squared, and because that is a constant, that would be 0. But this is substituting, then differentiating. Here we differentiate, then substitute. So it's all about the order of events. Okay. Other multiple choice questions? We did. We did. Number 10. Okay. Number 10 is a matter of executing carefully, and as long as we go step at a time, one derivative rule at a time, we should be okay. So tell me how it goes, you. Put your work away and just do it clean.
It goes like, so 1 over cosine pi over x
Yep.
times dy dx
DDX.
dx cosine pi over x.
Great. Keep going.
So it will be negative sine pi over x
Yep.
times ddx pi over x.
That's right. Keep going. I'm going to stack my terms over here.
X times dx pi,
Which is
0, minus pi times 1,
yep.
x to the x squared.
Yep. And you can get there faster by rewriting this as pi times x to the minus 1, so that I get negative pi x to the minus 2, which is exactly the same as what you have here. Okay? So now having done that, how does it simplify? Yes, definitely negative tangent over here. And what about this? Negative pi should be over x squared. And then you simply look for an answer equivalent to that.
if it's positive.
Yes, because negative times a negative is a
Oh,
positive.
right, yeah.
Yeah.
I didn't, yeah.
Good.
Is it fully executed once we're going over hours?
I'd take any, but the bell's about to ring, so here's what I want you to do. Several things. We are aiming for improvement. It's not about the, I got a grade, I'm happy with them, and move on. You know, we are aiming for improvement. So over Christmas, I want you to do the following things. Number one, as I said, I'm going to record a video. I'll actually put 1, 2, and 3 on the video. So you're going to watch that video. Number two, I want you to rework questions that you had difficulty with so that you are doing them correctly. And the purpose of that is for you to practice doing it how? Correctly, so that when you go to a test, you will do it correctly. Yes. Then, the next thing is that there may be other questions that you were not able to get, and I would like for you to start a discussion on Edmodo on those questions. Okay? So we're going to have rework and Edmodo, and the final thing is have a wonderful Christmas. See, well, we're done. Yeah, don't.